I'm Stephen Foskett from Gestalt IT, and I am here at Flash Memory Summit, and I am catching up with some of the interesting working groups and projects that are helping to improve the storage industry for everyone. And that's why I wanted to talk to Shyam about SDXI. Well, not a lot of people are going to be familiar with this, so I'm going to give you a chance. Tell us, what is SDXI?
So SDXI stands for Smart Data Accelerator Interface. So this is a new standard from SNIA that standardizes memory-to-memory data movement and transformation.
When we say memory-to-memory data movement, we really mean memory-to-memory. So right now there's a lot of ability to do data movement, but pretty much most data movement happens in at the application layer.
That's right.
Or at the layer of sort of a third-party application even, where and it involves lots and lots and lots of different kinds of data movement. Essentially, you have to go find it, you bring it into memory on this host, you run it through an application, the application sends it over the wire, the other one does all sorts of things. What we're talking about here is basically direct memory to memory between hosts, right?
That's right. So if you actually see a common application stack all the way from the user level software down to the place where the hardware is doing anything with that memory, you have multiple layers of software in between.
Yeah.
So you have user level software trying to do memory copies from one process space to the other process space, or maybe from a user address space to a kernel address space. Inside the kernel as well, there are like multiple times software copies happen, just being, sometimes it's from a specific area in the kernel to a DMA-able area in the kernel. And then, an I/O device or some other device may also again do a DMA. But if you look at most I/O devices, they're usually like targeting memory for either a source or a destination. They're not doing both memory to memory. So this is kind of a new thing where if you had DMA devices or memory to memory data movers that could do like from a source buffer space to a destination buffer space, now you can allow applications this interface and eliminate a whole bunch of buffer copies, essentially.
And I think that maybe some people might be sort of like, wait, what are you talking about here? But it's actually pretty cool. I mean, we're talking about basically like a mind meld between two servers.
Exactly.
Servers that are dissimilar, that they may be running different kinds of software. And this is a standard-based interface, which means that we could have servers moving data between them in a variety of different ways. And this would be really exciting for a lot of different applications, right? One that jumps immediately to mind is virtual machine migration. And I think that that's probably one of your first use cases, right?
Yep, absolutely. So the standard has been defined or designed in such a way that you can easily virtualize it. Almost everything is like a memory structure. All the states are like, well architected, which means that there are no hidden states. So an accelerator, the problem with it is how do you stop it at a well-defined boundary and pick up what you were doing with that accelerator in a different host? So the standard has been designed grounds up to allow you to, stop, quiesce, and resume it from a different host so that you can continue with doing the acceleration kind of an operation. So that's one of the big things that we are trying to solve with this standard.
Yeah, and I think that's really a pretty cool thing. I mean, you get what he said. You would be able to like stop a running virtual machine and resume it somewhere else on a different host in a standards-based way.
Yep.
That is theoretically multi-platform, multi-vendor, well supported, instead of being some kind of a proprietary thing.
Absolutely. So this accelerator interface is kind of like form factor independent, and also you could. What that means is you could have this accelerator interface in one CPU family, and it can also be instantiated in a different CPU family. And you could also have this accelerator as like an add-in card, like an FPGA card or an I/O card or a GPU card. So the structures that we are standardizing is applicable for both integrated CPU implementations or discrete implementations. And that allows us to be like vendor neutral. The same programming interface now can be followed independent of what the backend implementation is.
And of course, those of you who've watched Gestalt IT closely, you probably tuned in for our Utilizing Tech podcast series. And season 4, we focused on CXL. We talked all about CXL. If you're starting to think, wait, this sounds really interesting in the context of CXL, which is going to bring the ability to do shared memory and expanded memory and a lot of applications there, they're right? This has relevance in CXL.
Absolutely. So the standard is basically interconnect independent. So in the base version 1.0, we did give a PCIe device binding example. What that means is an SDXI accelerator device could be a PCI device. But it's also interconnect independent, which means you could be moving the DMA bus could be a CXL bus. So CXL is also a interesting technology for data movers like this because it does two things. One, it increases a system's memory address space. So the SDXI 1.0 version spec is defined for data movement within the host. So which means that as soon as you increase the system physical address space of a system using CXL, now you have a larger memory footprint that you could use your data mover for things like tiering, for hot, cold kind of memory data movement operations. The second thing CXL also allows for, or actually makes it good for these kind of data movers, is it's pooling memory and sharing memory construct, which allows for different hosts to share the same memory. Now when you combine this with a data mover like this becomes not just a intra-host data mover, it could also become an inter-host data mover. And that's why we are also very excited about how this plays a role in a CXL-enabled ecosystem.
Yeah, and I think that's the most important thing. When I was talking about CXL, when I talked to some of the founders of CXL, one of the things that struck me is that CXL sounds an awful lot like a storage array except for memory. It has the same kind of sharing and expansion and capabilities. And one of the things that, of course, that we realized with storage was that the killer app isn't necessarily just being able to have more of it. The killer app is the things you can do with the storage once you have a more flexible environment. Things like snapshots and copies and clones and moves. Those are the things that sold storage arrays. And it sounds to me like SDXI is going to do a lot of that for memory.
Oh, you hit the nail right at the head. So as we are doing these kind of memory-to-memory data movement, we are also standardizing things like transformation, different kinds of operations that you want to do as you're moving data. So think about any kind of POSIX style memory operation that you did, not just memcopy, memfill, repeating zeros, or even things like memory-based snapshots, or trying to do like compression as you're moving the data, or encrypting as you move the data. So what the standard allows you is it brings all of these kind of memory-based operations into the same framework, so that vendors can standardize on the structures while bringing their innovation in their actual implementations. And so this actually democratizes memory-based operations, kind of like storage did for us.
Yeah. And one thing I'll call out too there, you mentioned security, you mentioned encryption. This is a huge consideration as systems get more and more complex, whether it's UCIe with multiple chiplets from multiple vendors, whether it's CXL with systems talking to each other in really unprecedented ways, whether it's just the regular proliferation of expansion and flexibility. All of these things need the ability to do security and to secure data, and to especially, as strange as it sounds, to secure memory, because once memory is more flexible and fungible, we need to have security protocols. And it seems to me like SDXI could provide a basis for some of those things.
Oh, absolutely. So let me kind of peel it in a different way. So when 1.0 came about, we designed a lot of it for within the host. So which means that a lot of the memory protections that we relied on was within the host, say something like an IOMMU, which allows you to reach into address spaces. If you're not allowed to reach into that address space, you would not get access to it. So we designed all of that into the standard to make sure that when you're moving from one address space to another address space, we'll make sure that you're actually allowed to do that. Now, as we expand to these different use cases, which includes things like how do you protect it if it's confidential memory, or how do you do it if you want to encrypt it along the way? How do you do actually double encryption, because you want the link to be encrypted but also to the data to be encrypted? So all of these are the kind of things that the technical working group inside SNIA is thinking about, and we like where we are going. I think the standard has a lot of room to grow in terms of how it can play a larger role in this expanding memory ecosystem.
So another aspect of the industry that we've been talking about a lot and that's been getting some attention is computational storage, which combines storage with processing so that processors and accelerators can directly access and act upon data without having it go through a big CPU-bound application. Does SDXI have relevance in computational storage?
Absolutely. So one of the key things that SDXI also helps is reducing the data movement by cutting down the layers of software that is needed to perform the data movement. There are also memory spaces across the system. There are system memory spaces, and there are device memory spaces, and then there are spaces across devices that you may want to do data movement with. So SDXI can play a great role in moving data to the right places for the computation to happen. It can also play a role in performing data transformations or computation as it's moving the data. So we have a subgroup in SNIA especially to think about this. Like, how does SDXI fit into a computational storage architecture? Or what kind of features does computational storage need that can be satisfied with an SDXI interface? To that end, there are various kind of ways to imagine where SDXI could reside. It could reside as a host interface. It could also reside as an interface within the storage subsystem. So there are various ways that SDXI can complement the efforts for computational storage architectures.
So this all sounds very exciting, but of course it's new. This is something that was just announced. When might we see products that do what we've been talking about here?
Yeah, absolutely. So I think we've got close to 30 industry members and almost 100 individual members working in the group. And so we hear people are trying it. They're not yet public, so it's a good estimation that when shortly 2024 is a good time frame to think about products coming out in the public domain.
Well, that's really interesting. I think that it's important as well that this is not just something that one company is working with, and that it's an industry standard. That's what SNIA does. That's what SNIA is all about. And I think that it's critically important that functions like this are implemented in a standard way. So we are going to be talking more about this at Storage Developer Conference. We're actually bringing Storage Field Day to Storage Developer Conference in September. We'd love to have you join us there. If you go to storagedeveloper.org, you can learn a little bit more about that. Before we go, where can we continue this conversation and learn more about SDXI?
So absolutely, we are going to be there at the Storage Developer Conference. We will have a presentation, maybe more than one presentation at Storage Developer Conference. If folks want to learn more about SDXI, they can join snia.org/SDXI. We have the version 1.0 specification out there. We also have a lot of videos that we have presented at various conferences in that page. If you are looking to join the technical working group to influence the next version of the spec, you could shoot an email to sdxi-twigchair@snia.org. If you are looking to join the software development efforts, we recently created a software subgroup within SNIA. That's where some of the software development activities are getting discussed. You can come join us there. If you are interested in how computational storage and SDXI can play a role, we also started a new subgroup inside of SNIA for how SDXI plays a role in computational storage use cases. So there are multiple ways to join and work with us in this effort. Looking forward to it.
Thank you very much for watching this video. If you'd like to learn more, do check out SNIA, SNIA.org for more information about all of these industry standards. Also, check out videos like this. You can find them on YouTube at Gestalt IT Video. You can also find out more articles like this one at gestaltit.com. Thanks for joining us, and we'll see you soon.